Good morning, God bless you, and peace be with you. I'm Ana Margarita Esese, the leader of Group 3, and together with me are Janine Miguela Montenegro, Chelsea Clarice Guevara, Rafael Vincent Nicolas, Miguel Ivan Ong, and James Bartolome. We are students from Grade 12 St. Philip and form count of soil within the area of Piggery Farm.
Hey everyone, I'm Miguel Ivan Ong from Group 3 of St. Philip, and we are presenting an experimental research entitled Coliform Count of Soil within the area of Piggery Farm. The background of the study will help in determining the main and specific questions and the reason why this study is being conducted. Environmental problems. Some environmental problems have been rising, and according to Cohen, although awareness about the need for environmental stability has not been entirely spread throughout the world, many are still concerned about this. Land and water bodies experience these problems. Both land and water bodies are greatly affected by this. And based on the world counts, the lifestyle of human beings, and their overuse of natural resources causes pollution. Soil bears the biggest burden due to animal husbandry. As stated by Ashraf Ma and Yusuf, soil bears the biggest burden of environmental pollution because it is the universal sink. It is often caused by agricultural effluents from animal husbandry, uncontrolled sewage disposal, and other liquid waste coming from domestic use of water, industrial waste which contains different pollutants, and irrigation water drainage and urban runoff. Groundwater percolation. With this, another example of pollution which may be brought about by soil may be introduced, and it's groundwater contamination. And according to Murali and Manikam, it is commonly caused by human activities where pollutants are stored and spread on our beneath land surface. Based on article by U.S. Geological Survey, disposal of waste can also affect groundwater quality, and pesticide and fertilizers that seep into farm soil can eventually end up in water drawn from a well. Pig production industry brings fecal coliform. This connects to the emerging problem that piggery waste are contributing to the society. According to Catalo, Narod, and Tionco, the societal concern about the negative effects that the pig production industry brings, particularly with regards of the disposal of waste, are emerging, and this opens the concern about the fecal coliform bacteria as microbial indicators of soil quality. These bacteria are found in the intestine of warm-blooded animals such as pigs, and based on Penn State's extension, they are commonly found in soil and surface water. Contamination. This fecal coliform causes contamination, and it was stated by Maram Krisin and Ian that microbial contamination of water was related to well depth and was common in dog wells. A study by Garcia also revealed that the primary source of groundwater contamination are the waste released from drains and septic tanks. Another study by Balkher also stated that most of fecal coliform bacteria were found to be present in the first few centimeters below the column inlet, and the profile of the bacterially and exponentially decrease with as depth increases. Lastly, a study by Invik Barkema revealed that samples taken from private well were more often positive in total coliform or E. coli compared with untreated public well samples. This study strengthened the purpose of this research. For the rationale, the purpose of our study is to determine the coliform count of soil samples within the area of piggery farm and compare them in terms of distance from the piggery farm. The main question in the study is what is the effect of piggery waste on the coliform count of the soil within the area of piggery farm. The researchers also sought to answer the following questions. How are the physical properties of soil, namely moist soil consistency, texture, and color compared in terms of its distance from the piggery farm? How is the coliform count of soil compared in terms of moist soil consistency? How is the coliform count of soil compared in terms of texture? 4. How is the coliform count of soil compared in terms of distance from piggery? 5. Is there a significant difference on the coliform count of soil in terms of moist soil, consistency, texture, and distance from the piggery farm? Germ Theory by Louis Pasteur, Joseph Lister, and Robert Koch. In medicine, states that certain diseases are due to the invasion of body by microorganisms, or organisms that are too small to be seen except through a microscope. This helped because it states that negative effects of microorganisms, which is group where coliform bacteria is included, to the body. It was also stated by the United States Environmental Protection Agency that microorganisms can be found all over Earth's surface and are found in human sewage and animal waste. Consumption of drinking water containing microorganisms leads to a gastrointestinal illness and infections. Lastly, according to Vengslovsky, land-applied manure represents a major supply of microorganisms distributed across the landscape. It is brought to surface and groundwater resources. Pathogens survive and grow in manure as it meets the condition in order to provide the necessary nutrients and protect them against UV radiation. Desiccation and increased temperature concepts support the study by stating the manure helps in the survival and growth of bacterial pathogens such as coliform.
Conceptual frameworks where our independent variable is the area within the piggery, and the dependent variable is coliform count of the soil. For the process, the researchers use an experimental design, and the method for testing is coliform count testing. The output of this study is coliform count of soil within the area of piggery farm. Research hypothesis. For the first null hypothesis, the distance in km radius of the deep well site to the piggery does not significantly affect the coliform count in the soil samples in 1 km, 2 km, 3 km, and 5 km radius from the piggery. For the first alternative hypothesis, the distance in km radius of the deep well site to the piggery significantly affect the coliform count in the soil samples in 1 km, 2 km, 3 km, and 5 km radius from the piggery. For second null hypothesis, the moist soil consistency of the soil samples does not significantly affect the coliform count in the soil samples in 1 km, 2 km, 3 km, and 5 km radius from the piggery. Second alternative hypothesis, the moist soil consistency of the soil samples significantly affect the coliform count in the soil samples in 1 km, 2 km, 3 km, and 5 km radius from the piggery. Third null hypothesis, the texture of the soil samples does not significantly affect the coliform count in the soil samples in 1 km, 2 km, 3 km, and 5 km radius from the piggery. For the third alternative hypothesis, the texture of soil samples significantly affect the coliform count in the soil samples in 1 km, 2 km, 3 km, and 5 km radius from the piggery. The definition of terms. Coliform count is conceptually defined as the number of coliform colonies found in the incubated sample. The coliform colonies counted in plates, or the colonies on the filter paper that can be counted. It is operationally defined as the number of total amount of coliform bacteria in the soil sample. Moist soil consistency is conceptually defined as a measure of the strength of the soil materials as held together, or the measurement of the resistance of soil to rupture and deformation. For moist soils, it is expressed as loose, friable, very friable, firm, very firm, and extremely firm, or a measurement of the moisture content of soil approximately midway between air dry and filled capacity or the firmness soil, which varies the water content of the soil. It is operationally defined as a physical property of the soil sample collected, and it's determined by the ability of a soil to stay intact after application or pressure through pinching. Soil texture is conceptually defined as the composition of the soil in terms of the amount of small, medium, and large size, the proportion of the sand, silt, and clay-sized particles that make up the mineral fraction of the soil, or the particle size distribution of the soil fraction, or which highly depends the ability to retain water by changes in permeability. It is operationally defined as a physical property of the soil sample collected, and can be determined by the ability of soil to retain its shape and increase the strength of the stickiness and stiffness after being thrown in a hard surface. Significance of the study. This study benefits the piggery owners by letting them know the effect of piggery waste to the presence and amount of coliform in the soil. The Santa Maria water system, through keeping them aware of the presence of coliform in their soil, thus letting them know that an action should be done in order to aid this problem. The citizens of Santa Maria, by letting them know about the negative effect of piggery waste and reminding them that they must be careful of the usage of their resources. Future researches, by helping the future researchers through providing them with resources with regards to the coliform count in soil that may help them in the future. For the students conducting the study, through informing them and keeping them aware of the environmental problem that the world is facing today. And so, this reminds them to keep the environment safe for the future generation to have a healthy environment. The scope and delimitation. The study focused on the coliform count of soil within the area of a piggery in Katmuan, Maria, Bulacan. Through testing soil samples gathered 0.5 meter below the land surface from 1 km, 2 km, and 3 km radius from the piggery to the deep well site, and another soil sample from the deep well site located at Santa Maria, Bulacan. The soil samples were taken to the Product Quality Control and Research Laboratory in the Philippine Coconut Authority in Diliman, Quezon. The 4 samples underwent the total coliform count test. Results shown the coliform bacteria were present, and their total count. The physical properties of the soil sample that were analyzed were limited to the moist soil consistency, texture, and color. The study were limited to the fecal bacteria of pigs and only evaluated the coliform bacteria present and coliform count.
Chapter 3 presents the research design used in this study. This chapter also explains the procedures for preparing the soil samples, the testing used in order to analyze the samples taken, and the statistical tool used in order to determine whether to accept or reject the null hypothesis. The research design for this study is experimental because the researchers tested the soil samples that connects to the groundwater in order to determine the coliform count of these soil samples within the area of the piggery. The researchers studied soil samples coming from areas near the piggery in order to determine if it is contaminated with coliform bacteria. Santa Maria Water District obtained its water supply from different ways. One is getting water from 22 production wells located in various sites within the service area of the water district. The researchers used the total coliform count test on the soil samples. Only one trial was done because accuracy were obtained since the Philippine Coconut Authority uses machines and equipments that gives accurate data. Preparation of soil samples. The soil samples were taken 0.5 meters deep from 1 kilometer
2-kilometer and 3-kilometer radius from a piggery farm, and 1 sample from the deep well site itself, which was also 0.5 deep and 5-kilometer radius away from the piggery. The said piggery was chosen by the researchers for this is the nearest one to the deep well site of Santa Maria, where Santa Maria Water District take their water from. The Philippine Coconut Authority's laboratory expert recommended to provide at least 250 grams of each soil sample, but the researchers wanted to ensure that the soil samples have adequate amount, so they took soil samples and weigh approximately 500 grams each that were put in 500 grams containers. It does not affect the results by the excess amount of the soil samples because the samples were weighed again in the laboratory. All in all, the total number of soil samples taken were 4. 1 sample for 1 kilometer, 2 kilometer, 3 kilometer radius from the piggery farm to the deep well site, and 1 from deep well site itself. And all of the samples were taken 0.5 meters below the surface. The soil samples were requested to be stored in a clean container and in a cool place in order to prevent the death of the coliform bacteria. Therefore, the researchers placed all the soil samples in 4 different clean and unused plastic containers with numbers that indicated the correct order of the samples drawn from the closest area to the piggery to the farthest area from the piggery, then wrapped with plastic wrapper to avoid any leaks and stored in an ice box right after they were collected, and were later transferred in a refrigerator so that the samples were kept cool overnight. The next day, it was retransferred to an ice box to ensure that the soil samples were kept well in a cool place when it was given to the laboratory of Philippine Coconut Authority. The physical properties of the soil, particularly its consistency, texture, and color, were determined through an observation using 3 different testing methods. The first test was field test for moist soil consistency. Second was the throw the ball test. These 2 tests are both from Food and Agriculture Organization of the United Nations. And the third test was Munsell color chart. Field test for moist soil consistency was used to determine the consistency of the soil. The field test for moist soil consistency, which was done through pinching the ball-shaped soil samples and seeing how loose or firm the soil samples were, through differentiating the amount of soil left at hand after the application of pressure. Throw the ball was used to determine the texture of the soil. The throw the ball was done through throwing ball-shaped soil samples on a wall and seeing how coarse or fine the soil samples are through observing the behavior of the soil's sediments. Munsell color chart was used to determine the color of the soil. The test was done through comparing the soil samples to the Munsell color chart. Analysis of soil samples. After gathering the soil samples, it was taken to the Product Quality Control and Research Laboratory in the Philippine Coconut Authority in Diliman, Quezon City for the coliform count testing. Upon the researchers' arrival, with the help of an authorized person in the laboratory, the soil samples were taken out of the icebox and the containers were wiped after the plastic wrap around it, which protects the sample from having leaks, were removed. Then, the soil samples were reweighed by one of the laboratory experts to ensure that all the soil samples reached the recommended amount for the coliform count testing. The soil samples were taken inside the laboratory after being reweighed, and the researchers were informed that the rest of the process was done by the laboratory experts and the testing took 15 days before the results were released. Statistical tool. The researchers used one-way analysis of variance, ANOVA, to determine whether to accept or reject the null hypothesis. One-way ANOVA was used because coliform count was compared in terms of 4 different distances, namely 1 kilometer, 2 kilometer, 3 kilometer, and 5 kilometer radius from the Piggery farm.
Moving on to the summary of findings supported by the Chapter 4, which contains the data gathered by the researchers. The first finding is about how our physical properties, namely moisture consistency, texture, and color, compared to its distance from the Piggery farm. The study shows that the soil samples from different kilometer ranges from the Piggery farm to the depot site differ in terms of their physical properties. The soil from 1 kilometer ranges has a very friable consistency, a medium texture, and a brown color. The soil from kilometer ranges has a firm consistency, a fine texture, and a very dark gray color. The soil from 3 kilometer ranges has a loose consistency, a coarse texture, and a dark grayish-brown color. The soil from the depot site, which is 5 kilometer ranges from the Piggery farm, has a loose consistency, a moderately coarse texture, and a dark gray color. The analysis of Table 1 of Chapter 4 also reveals that the soil from 2 kilometer ranges from the Piggery farm has the highest moist soil consistency, finest texture, and darkest color. The first findings were made through an observation using 3 different tests for physical properties, namely the field test for moist soil consistency, the through-the-ball tests, which were both from the Food and Agriculture Organization of the United Nations, and the Munsell color chart to determine the color of the soil. For the second finding, how is the coliform count compared in terms of moist soil consistency? Using the Table 2 of Chapter 4, the study shows that the soil sample, which has a very friable consistency, has a coliform count of 2,600. The soil sample, which has a firm consistency, has a coliform count of 15,000, and the soil sample, which has a loose consistency, has a coliform count of 675. The analysis of Table 2 of Chapter 4 reveals that the soil sample, which has the highest coliform count, has a firm consistency, while the soil sample, which has the least coliform count, has a loose consistency. For the third finding, how is the coliform count compared in terms of texture? Using the Table 3 of Chapter 4, the study shows that the soil sample, which has a medium texture, has a coliform count of 2,600. The soil sample, which has a fine texture, has a coliform count of 15,000. The soil sample, which has a coarse texture, has a coliform count of 470, while the soil sample, which has a moderately coarse texture, has 880 coliform count. The analysis of Table 3 of Chapter 4 reveals that the soil sample, which is the highest coliform count, is the one that has a fine texture, while the soil sample, which has the least number of coliform count, is the one that has a coarse texture. The analysis of Table 4 of Chapter 4 reveals that the coliform count in terms of distances in kilometer radius do not follow a particular order. The soil sample, which has the greatest coliform count, was taken 2 kilometer radius from the Piggery farm, while the soil sample, which has the least coliform count, was taken 3 kilometer radius from the Piggery farm. The fifth finding is there a significant difference on the amount of coliform bacteria in soil in terms of moist soil consistency, texture, and the distance from the piggery farm? Using the tables 5 and 6 of Chapter 4, the study shows that with the use of analysis of one variance or ANOVA, it was revealed that in terms of moist soil consistency, the computed critical value was 7.7, with a p-value of 0.25, and the computed f-value was 1.84. In terms of texture and the distance from the piggery farm, the computed critical value was 5.99, with a p-value of 0.22 and a computed f-value of 1.88. The analysis of tables 5 and 6 of Chapter 4 reveals that the null hypotheses are accepted, since both of the f-values from tables 5 and 6 did not reach the critical values.
The first conclusion states that coliform bacteria are present in the soil samples. This may be supported by an article of Manila Bay Coordinating Office stating that coliform bacteria can come from human and animal waste and are also found in water, plants, and soil. Also, Penn State Extension states that bacteria are much more common in springs and shallow wells compared to deeper wells, because soil and rock naturally filters as surface water infiltrates into the ground, and these statements are evident in the researcher's study. The second conclusion states that the physical properties of the soil samples affected the coliform count, because the findings of the researchers show that the soil sample taken from 2-kilometer radius from the piggery, which has the most firm consistency and the finest texture, has the highest coliform count with a value of 15,000. And the soil sample that has the lowest coliform count, specifically 470, is the soil sample taken from 3-kilometer radius from the piggery, which has the most loose consistency and the most coarse texture. This may be supported by a study conducted by Pinilla, Cordoba, Fuentes, and Montoya, revealing that the survival of fecal coliforms in the soil depends on the conditions of the moisture of the soil. Their study shows that fecal coliform concentration were higher in soil having a greater moisture level, and lower in soil with lesser moisture level. And like in this study, the moisture level of the soil samples taken from Santa Maria, Bulacan also had an effect on the coliform count of the soil samples. The third conclusion states that the feces from the piggery farm may be one of the sources of the coliform bacteria that was examined in this research. This may be supported by a study conducted by Brandt and Ratnayaka, which states that coliform bacteria are greatly related to hygiene, and its occurrence is most significant in feces. The fourth conclusion states that the findings of this study shows a health and an environmental risk for many Filipinos, especially to those living in Catmon and Parada, Santa Maria. It was stated by Washington State Department of Health that most pathogens that contaminate water supplies come from the feces of humans or animals. Manila Bay Coordinating Office stated that positive coliform bacteria tests for food and water means that there is a possibility of fecal pollution, and are often associated with the outbreak of various diseases. Lakwata also states that once ingested, fecal coliforms can cause gastrointestinal infections, and they can also cause infections to a person's ears, eyes, nasal cavity, or the skin. Also, as stated by Ashraf, Maa, and Yusuf, domestic garbage, municipal sewage, and industrial wastes, when left in small amounts or improperly disposed, affect health of human beings, plants, and animals. Gomez also stated that up to 80% of animal waste was directly dumped into the environment without proper treatment. Lastly, a study conducted by Lagbas and Habito reveals that well water is not suitable for human consumption if it is not thoroughly treated because of fecal coliform contamination. Since this study exhibits presence of coliform bacteria in the soil samples, these statements furthermore prove that there is a risk for the health and environment of people, especially those who are living in Catmon and Parada, Santa Maria, Bulacan. So as stated by the ANOVA computation, the distance in kilometer radius of the soil samples from the Piggery farm to the deep well site does not significantly affect the coliform count in the soil samples. The moist soil consistency of the soil samples also does not significantly affect the coliform count in the soil samples. And the texture of the soil samples does not significantly affect the coliform count in the soil samples as well.
The researchers recommend that the other piggery farms must be examined, particularly the soil. The soil must be tested to know whether it does or does not contain other pathogenic bacteria. And if it does, an action must be done because it is harmful for the people living near the piggery farms, and it would affect the safety of the deep well sites and the water drawn from it. The texture and soil consistency of the soil has a pivotal role, and it must be considered in determining the presence and amount of coliform bacteria in the soil. The people must be cautious at all times, especially those who live near piggery farms, because the concentration of the coliform bacteria in the soil near them might be harmful for them due to the bacteria that are found in the soil, which may cause harm to their health and have negative impacts to the environment. Lastly, the researchers recommend that preventive measures should be applied in order to avoid the threats of coliform bacteria, like improvement of water treatment.
And that ends our research presentation about coliform count of soil within the area of Piggery Farm. Thank you for listening. God bless you and peace be with you.